be able to construct the trust path.
basically store any value you want to have. To compare attributes, you have separate to the attribute syntax matching rules, which define how a matching would be true or not true. For instance, case exact match and case non-exact match. Yeah, there are special attributes. One very important attribute is the object class attribute, which characterizes the entry, for instance, a person or an organization or a country. So with the object class, you define which other attributes should be associated with this entry. So, for instance, a person can have a name, a telephone number, a fax number, email address, and so on. And this is defined in the object class. And the entry has at least one object class attribute. You could have more than one. Okay, there are two possibilities in the standard for pointing from one entry to the other. One is alias object name, which is only a pointer, and a see also attribute, which is you have data in one. No, I don't. Sorry. Which is you have data in one entry, and then you want to point to another entry, and then you use the see also pointer. So this is how the directory information base would look like. You have entries. Every entry has several attributes. Every attribute has a type and a value, and there's a distinguished attribute value and other values. This is important for the naming. So if you have this common name attribute for naming the object, the entry, then it's one of these, which is the distinguished attribute value, which is part of the DN. The other values are just additional information. You can distribute the data among several servers, which is a very important feature, which makes the technology very scalable. And you can, well, it's just like World Wide Web, like web servers. You can have LDAP servers that have parts of the data. And you can just choose which part of the hierarchy is contained in which server. It's a client-server system. Since LDAP version 3, this is true. Before, LDAP was just an access protocol for X500. But now LDAP is an own technology, grown up, so to speak, and is about to replace X500 technology. Yeah, there are a few differences, but well, basically you can well, always tell the client if one server doesn't have the data, the server is able to give back a referral to tell the client where it ought to look for the data the client requested. There are a lot of security mechanisms already defined in the LDAP standard. You can have a simple bind with password, which is just like a user login. Instead of the user name, user ID, you would take the DN of your entry. But you can protect this as well via TLS, for instance, so the password doesn't go in clear text through the net. You can use ZASL mechanisms. That's a whole group of authorization and security. Well, ZASL stands for Simple Authorization and Security Layer. It's a group of mechanisms you could use. And you can define access control. So the server, you can configure the server. You can tell him who is allowed to see which data, and not only on entry level, but also on attribute level. Yeah, you can do bind, unbind for authentication, for initiating the session, and you can do searches, and you can modify the data with the add, delete, and so on. By the way, how much time do I have? Until? Give me... Huh?
20 minutes more, definitely.
20 minutes more, okay, until half. Oh, that's fine. There's a RFC defining an LDAP URL. which is just like a HTTP URL. Instead, you have HTTP :// you have LDAP ://. Then, just like HTTP, a host name and a port number. Then the base DN defines the namespace of the server. Then you can have the attribute list. That's the attributes you really want to see. For instance, if you're only interested in the telephone number, you say telephone number here. The scope says where in the tree to search for, whether the whole subtree or only one level or only one entry. And then you can define a filter, what to use for. And there are lots of extension mechanisms, but I won't go into them here. Another very important thing is you have a common data interchange format called LDIF, and it looks quite, well, straightforward. You first have the DN, and then you have the attributes. It's handy to have the object class attributes on top, but you don't really have to. It's just an aggregation of attributes combined in one entry. So who talks LDAP? There are a big number of LDAP implementations. One open source implementation called OpenLDAP, which is constantly maintained and producing new versions from time to time and increasing its stability. It is very stable and increasing the features, the security features and so on. But there are also commercial implementations by Sun, Netscape, Allianz, IBM, Syntegra. There are lots I could mention here. All other directory implementations have LDAP interfaces. So all X500 implementations do Novell Directory Services speaks LDAP. Microsoft Active Directory speaks LDAP. And there are many client applications, mail agents, browsers, PGP clients, and so on. Okay, so let's come to the indexing protocol and metadata. Common indexing protocol is also an IETF, standardized in IETF RFC. It's no draft standard yet, but maybe this will change in the future. It's an experimental standard by now. Working with MIME wrapper around index objects and defining transport protocols, email, HTTP, and FTP. There are different index object formats. One is for bibliographical data and one called tagged index object for directory data, which is very handy because it through the tags, you know that two attributes belong to one entry. Every server has an OID, which is called dataset identifier, and a base URI, which is important to generate the referrals. So when there had been, in the last couple of years, work to think about how to deploy common indexing protocol for the LDAP world. This is a concept originated from an EU project called Desire. You have a number of LDAP servers. You have a crawler that crawls the data, converts them into this tagged index object format, putting it to such an index server, and then you have patched LDAP index server, which talks with this, patched LDAP server, which talks to this index server to give back the client referral. So a client has a question, just asks the LDAP index server, and gets back a referral to the data server right there on the right-hand side. What could you do with it? We are just in the frame of the TF-LSD working on a white pages service, European-wide pages service. You could do metadata indexing with it, metadata, for example, about web pages, metadata about books, metadata about resources, very important in grid computing. You can set up a certificates server and then with a mechanism which is newly defined, index the attributes or the fields of a certificate. Here's the draft where you could see how this could be done. You could have a web service repository instead of the UDDI technology, which is now favored for web services, but I just want to say you can use this for any big amount of distributed data. For instance, distributed metadata, and now I'm coming to more in direction to semantic web again. So we have a web page and we have data about this web page, for instance, keywords defining what this web page contains. And there are lots of metadata formats for doing this, and a variety of representation of these metadata formats. XML is, of course, an important technology for describing metadata, and there is a technology called Directory Service Markup Language, which is sort of a bridge between XML and directories. So you could map every directory information in XML, and vice versa. You could transform XML information into directory information. There has been a project using LDAP for metadata called Isaac Network. But to come to the ontologies, I'll skip that. LDAP, Common Information Model and Ontologies, is my last bit of my presentation. But first, let's have another reflection about knowledge. What is knowledge? How can you teach a computer knowledge? Metadata are data about information, and ontologies are concepts and relations between them. This relates to the definition of knowledge I gave you in the beginning. You have, concepts and any concept you can think of, and the real knowledge is to know the relations between these concepts. There's a small example here with ontologies you can realize that you give the computer some information and the computer will have more information than you put into it. So if you put in, for instance, parents have children, and if you put in mother is a female parent, then the computer will know that mothers have children without you having told the computer. And that's how ontologies work, and that's how ontologies can map knowledge and map more knowledge than you put into it. There are lots of attempts to define formats, how to map such ontologies. The current, best solution seems to be DAML plus OIL, which is the combination of a US attempt called DAML and a European attempt called OIL. And the whole thing is now coming to the W3 consortium, and they are working on a thing called WebOnt, which will be based on DAML plus OIL. I don't think I'll go into the details. It's just a matter how you can define concepts and relations between concepts. Properties and let's go to the first classes and properties in the speech of this schema. So my proposal would be, and this is just a proposal, I did try to find funding for this but didn't succeed yet, but I think it would be very interesting to see how you could store these ontologies with LDAP technology. Which would be, the vision would be you would have the web information via HTTP, and you would have metadata information about the web via another protocol, namely LDAP, as a metadata repository, and the metadata structured, the keywords of the metadata structured just as an ontology for the knowledge enhancement. So there is, you can have large scalability, as I tried to show you just now, by using the Common Indexing Protocol. You can have any range of metadata server. You can have 2, but you could also have 2,000 or 200,000. And with the Common Indexing Protocol, you could combine them into one information service. And the ontology data model could be based on a thing called Common Information Model, which provides a model for associations that can be used for mapping the relations between objects. I thought I had another slide on that. Maybe I had... Anyway, a common indexing model is a thing that started with thoughts about how to map router policy in an LDAP data model, how to define router policy so that you could put it into the net, so a single router would be able to get policy information out of the net to decide which packets to more fastly send through and which could wait a bit. The problem of policy is you have conditions and actions, and so this is also a very complex relationship you have to map between objects like conditions and actions. And but the common information model is more than that. As the name says, it tries to be a common model for every item, every object that will that exists in the computer world. So they want to map computers, services, devices, hard disks, printers, software applications, whatever. They define common attributes for these objects, and they also define relations between these objects. So basically, common information model is an ontology for computer-related things. So in such a model, an LDAP repository for ontologies, you could store multiple ontologies with links between different ontologies. You have special ontologies for biology, for agrosciences, for each science you have special ontologies, but you also have general ontologies. For instance, WordNet, which tries to put every English word in such an ontology system with the concepts and the relations between these words. Yes, and with the linking mechanisms and the hierarchical structure of directory services, you could link multiple ontologies together. Oh, there's my slide on common information model. I think I talked about all of it. Well, there's 3 layers in this common information model. A core layer, just the basic Lego bricks with which you can define the single objects. Then the common layer, where you have a standardized description of a computer, a service, a application, a policy, and so on. And then extensions, so the vendors could put their extras inside. Yeah, and this model is capable of describing the whole computer world, and thus is basically a special ontology on computers. Here's an example of policy. I just want to notify you that you have objects and you have an inheritance mechanism, which is easily mapped with the inheritance mechanism of LDAP, which I forgot to tell you about. You have aggregations and associations, which are the relations between these objects. And these people who invented this, they also invented a mapping for LDAP So you could put all this kind of complex information into an LDAP server. And we had somebody doing a diploma thesis on this, and we actually put it on an LDAP server, and it worked, and it was quite performant. Yeah, here's an example of such a relationship. So not only the objects are stored in entries defined by object classes, but also the associations, the relationships between these objects are stored in entries with special object classes like this one, for instance, which is a member of collection as aggregation used to establish membership. And yeah, well, other examples where you can see that the relationships can be vice versa. So you have one object here, and you have the relationship here that points to both objects. Okay, so with Common Information Model and LDAP, any kind of relations can be defined. LDAP provides object class inheritance, which is perfectly to map the inheritance mechanisms in Common Information Model. Also attribute inheritance, which is also important for ontologies. You don't, the properties can have sub-properties which can be mapped by such an attribute inheritance. Associations and aggregations can be mapped by object classes. Yeah, and this was it. So, yeah, basically it's an idea to use common, well-introduced technology like LDAP for a new thing which could be a technology for providing this wonderful semantic web Tim Berners-Lee is thinking of. Yeah. Thank you very much.
Okay. Thank you,
Any questions?
Peter, for sharing your ideas with us. Ladies and gentlemen, if there are any questions, we have enough time to take 1 or 2 or 3, whatever you think. Any questions? Yeah, please, could you go to the mic, just, please? Yeah, for the sake of our internet public. Thanks.
Thanks, Peter. Can you explain a little bit more, maybe go back to your introduction? If you say, well, this can all be done in LDAP, then the question is, and then what?
Pardon?
And then what?
And then what? Then
yeah, so you can do it in LDAP.
Yeah.
Why would you do it in LDAP, which was not constructed to do this?
Because in LDAP you have all the features you would need in addition. For instance, this possibility to distribute the data. You have a scalable database, and you need a very scalable database to store metadata on millions of web pages. I can't see any other technology which could do the job just as good as LDAP. Yeah. I mean, you have XML databases. That could be the alternative technology. But what I see there is that there are lots of proposals for the query protocol, for the query language, for querying XML structures. And there's not yet a standard on the query language. And if you have this query language standardized, then the problems begin. Then you want to have distribution. Then you want to have access control to the data. You want to survey who is going to input data, who is allowed to input the data, and so on. And all these additional features of a network database would have to be defined in the XML world. And my position is, why reinvent the wheel if you have a technology which is well introduced, which is used in many different application areas, and which could be used here as well?
Okay, I think we got an answer. Yeah, please, can you go to the mic? I'm sorry for that disturbance. You have to walk a little bit. So. You can go downstairs, yeah, sorry.
Excuse, you have done an example about routers, policy with routers, but I can't understand how it be possible, because I think that I don't understand if a router for every packet has to ask the database for the policy, or if there is a server that export the change of policies.
Yeah, I only took this as example because this is what we had been working about right now, to see how, if the common index or common information model is mappable in LDAP, and if such a service would be usable. The whole concept of policy in the network, it's called directory-enabled networks, was a buzzword 2 or 3 years ago, and people were very enthusiastic about that. And in theory, it was working. So it's not that the router would ask an LDAP server every time an IP packet comes to decide where to go to. There are other protocols, well, I don't know. Well, why not? This presentation was not about directory-enabled networks, but anyway, you have a policy decision point and a policy enforcement point, and a very fast protocol for that. So these two could be inside the router, and if they are not inside the router, you have COPS as protocol to put the information to the router. And this policy decision point, from time to time, gets the policy data from the LDAP server. So it's not that the IP packet will be sent, for every IP packet you will have an LDAP request. It is just via LDAP, the actual policy enforcement point gets the static information, and it will be updated via LDAP, but the information is at the router itself for the actual decision how to route the packages. But as I said, this is just an example. I just wanted to show that there are complex, even more complex problems like policy storage that can be handled with this model, and ontologies are not, well, it has to be seen how complex it is, but I just wanted to show that you can store different relationships between objects with this model. And this was just, the policy stuff was just an example where we actually did work on where I can say, yes, this worked, and if this worked, why shouldn't ontologies work?
Okay.
Yeah,
Yeah, we have a Michael upstairs. He was the first one, and then
Michael?
you. So.
It would seem to me that the use of relational databases would be especially suited for the semantic web. And as you noted, LDAP is not relational. So what do you think about that?
Well, LDAP is a hierarchical database, but it has a mechanism included for pointing, for relations between entries, and with this common information model, it has even more enhanced methods for defining relations. I'm not sure whether relational databases would be very good for the semantic web, because by now the problem of distribution of relational databases is a research item of the Global Grid Forum. There's a research group on that, which means they are thinking about having solutions of this single problem of distribution of relational databases in a couple of years. And I think you would agree with me that you need a distributed database for metadata on web pages.
Yes, I do agree with you on that, but I'm going back to the other comment where you said that you felt that LDAP was the right tool. And what I heard you just describe was making use of certain features within LDAP, which is not relational, to try and use it in a relational way. And that's, it sounds to me like round peg, square hole.
Okay, let's get back to ontologies. You have single-dimensional ontologies we all know about. These are classification systems. Yes, and classification systems are hierarchical, and are for the human brain. It seems that humans want to put hierarchies on the world they see. So they have any building, and church is a special building, and so on. So we think in hierarchies, and if we want to map our knowledge, the hierarchical mapping, hierarchical relation is the most important. And exactly this relation is inherent in the LDAP model. And in addition to that, of course, knowledge is not only mappable in hierarchies. You need additional relations between those objects, and these additional relations can be mapped via this common information model type of mapping, LDAP mappings. So I do think that even inherent in the LDAP data model, the inherent hierarchical principle of that data model is especially valid for mapping ontologies.
Okay, we will have one more question. I want to come back to your router example, because you made it sound like that LDAP should be a replacement for SNMP or COPS.
No, I didn't say that.
Do you want LDAP to talk to the policy decision point or the policy enforcement point? That's one question. The other question would be then, in these cases, if information changes in the LDAP tree, there's not a simple way that the LDAP tree tells to the router, listen, I changed. Usually, to my knowledge, but that might be a little bit backward, is that the router should poll every minute, did something change? No, I'm fine. Did something. So how is the status of that part?
Okay, your first question, it's definitely the decision point and not the enforcement point. And well, the second, I don't really know if I want to answer it, because I didn't want to promote DEN here. I know DEN is a good concept, but it hasn't been implemented in the routers yet. And talking to people from Cisco, they tell me, oh no, it's dead. We're not really interested. So I really don't want to defend directory-enabled networks here. What I see is that the same model is used in another IETF working group, IPsec policy, where they want to use similar mechanisms for mapping, for storing policy for IPsec. And well, there are a bunch of people working in this working group, and they do see that this model seems to be useful for such applications. But again, my current presentation was just an example, and maybe it's well, basically, if I get funding to do ontologies with that, I will have ontology examples in my next presentation. Yeah?
Okay, thank you, Peter, again, and thank you all for interesting discussion. We have to proceed to the second of the talks. It is titled "Sharing Knowledge in the Internet Through a Collaborative System," authored by the colleagues from Spain, Ruth Cobos Perez, Xavier Alaman, and Jose Esquivel. I apologize for my pronunciation of Spain language. Ms. Cobos Perez will have a presentation.
Thank you very much, and good afternoon. Okay. Okay, my name is Ruth Cobos. I'm researching about groupware system and knowledge management system in Universidad Autónoma de Madrid with Xavier Alamán and José Esquivel. And the title of my exposition is Sharing Knowledge in the Net Through a Collaborative System. For this time, we propose a web-based system, a group web-based system for constructor knowledge that is called NoCAD. The exposition is structured as follows. First of all, I began with a brief introduction. Secondly, we expose our proposed system, NoCAD. Next, I present some experience carried out with the system, and finally, conclusion and future work. Okay, the introduction. The necessity of systems that implement models for knowledge management is primarily related to business strategy solutions. Most of these solutions are oriented of management corporate knowledge. Some examples are Microsoft SharePoint Portal Server or Metaphor NuNet. But, however, we are interested in tools for educational and research activities. Some examples, because we think that we need tool or system for supporting academic communities. So we have developed a new web-based group-based system called NoCAD, that allows the crystallization of collective knowledge as a result of user interaction. Sorry. Oh. Okay. Our proposal, NoCAD. NoCAD stands for Knowledge Catalyzer, and this system intends to capture established knowledge about a given topic in the web in an asynchronous and distributed way, and without the need of an editor for managing the task. And this is possible through the knowledge crystallization process supported by virtual communities of experts. As I said before, NoCAD, the system, is a web-based client-server system. It may be classified as a group web tool because it allows collaborative work of a community of group of people for managing their collective knowledge, and users can work in the system in an asynchronous way. And the three main characteristics of the system are portability, because the system can run in any platform; adaptability, it can be adapted to the user needs; and scalability. NoCAD node may be combined to form higher other node. I explained this concept, NoCAD node, later. And the two main applications of NoCAD of the system is, on the one hand, the generation of quality educational material as the automatic result of user interactions with the materials, and on the other hand, the generation and maintenance of the collective knowledge of a research group. In short, NoCAD allows communities, a group of students or a group of research, to build places called NoCAD site or NoCAD node, where we can find the relevant knowledge about an area or topic. This is an example screen of the system, the NoCAD system. Here we can see a NoCAD site about operating system. In the left side, we can see the structure of the knowledge area. It's a tree structure. And in the other side, in the right side, we can see the description or contents of a given topic of the knowledge area. This description or document or paper, so on, are identified by the author name and the reading date, okay? And they are displayed ordered by their crystallization degree. This crystallization degree is displayed beside the identification of each document. NOCAT is a knowledge management system, so what kind of knowledge does the system deal with? Okay, NOCAT deals with explicit knowledge, that is the type of knowledge that we can transmit from one person to another through text or picture or any document. And the treated knowledge in the system is stable in time. So an example of this type of knowledge is the knowledge that we can find in encyclopedias or reference books. NOCAT organizes the knowledge in a tree structure, as you can see in the left side. Each node of the structure is a topic, and its topic or node is refined, is divided in a list of other nodes that are subject of the current topic, and each topic is composed of documents or description, that is a set of addresses of web document with sub-description. In each moment, the descriptions of a topic are competing for being the best descriptions of the given topic. Okay. And what is this concept, knowledge crystallization process? Okay. The knowledge crystallization process affects both the tree structure and the contents or documents. This process decides the lifetime of this knowledge element in the system, and their lifetime depends on the pattern of this usage. For example, in this graph, we can see the knowledge crystallization process of knowledge in form of descriptions or documents. And when a new document is added to the system, it is assigned a crystallization degree. And if this element of knowledge is consulted and it receives favorable opinions from the other user of the system, its crystallization degree will rise and the element will stay longer in the system. However, if one element is not used or it doesn't receive favorable opinions, then it will be eventually disappear from the system as a consequence of its crystallization degree going down. This knowledge crystallization process considers these two aspects. Firstly, as important as the number of users or their opinions is the quality of this user. That is, we would like to give more credibility to the opinion of experts and to the opinion of occasional users. And secondly, when a new node is created, the system has the bootstrap problem, because in the beginning we don't have enough critical mass in terms of people contribution to make the system run. So the most natural answer we were able to devise for these two aspects is virtual communities. A virtual community for us is a group of people that are considered experts in one and more related topics. And these virtual communities are constructed in terms of the tree structure. For example, the virtual community of this node is composed both users whose contribution, whose document crystallized in this topic and on related topic, on closed topic. In this case, author of crystallized documents on this topic, on the parent of the topic, on any of the children of the topic and any of the sisters of the topic form the virtual community of the selective topic. So this virtual community appears as a natural way of handling the knowledge area construction. There are two elements that make crystalline the system. First of all is the topic contents or documents or paper. And the mechanism of crystallization is that I show this slide. When a user contributes with a description of a topic and it crystallizes, the author receives a certain amount of vote that he or she may apply for the crystallization of other articles of other authors in the virtual community, in the same virtual community where his or her crystallized paper is located. And about the other element, the tree structure, if a member of a virtual community proposes to add a new subject of a topic or to remove a subject from a topic or move a subject from one topic to another topic, it will be necessary a minimum quorum of positive vote from other members of the same community for changing the structure. And finally, virtual community behave in a different way when they are just in the beginning and also in the later phase. So NOCAT proposed a maturation process that involves several phases, and rules for crystallization may be different for each phase. The knowledge evolution is the next. First of all, when a new node is created, especially when the node is the root node of a NOCAT site, there may not be many accredited experts to form the virtual community. So in this phase, the node works in the supervised mode. There is a steering committee in charge of many of the decisions that will be distributed in later phases. And most of activity in this first phase is about the construction, is related to the construction of the knowledge tree. The steering committee may decide to advance the node to the active status. In this moment, the steering committee is dissolved and knowledge crystallization is carried out, as I explained in the previous slide, with virtual communities. In this phase, most of activity is related with documents or contents, adding documents, voting documents, and so on. And later, the active community may reach the stable phase, when changes are rare and most of activity is consultation and few contributions arrive. However, if activity rises to a minimum again, the node may switch to the active status again. Sorry. We have tested NOCAT during 3 years with some communities, with communities of students at Universidad Autónoma de Madrid. These are some examples. The first and the second one are NOCAT sites created by a student of computer science during the 3 first years ago, and now, this year, they are working too. And the last one is a NOCAT site created by a student of pedagogy school during the last year, and this year they are working too. And in this year, we are starting new NOCAT site with researchers, with group of researchers. I'm going to explain in detail the first one and a little of the second. Okay, the first year of the first experience, we started with a NOCAT site with the name of the course, operating system. The structure was suggested by the professor, by the structure of the course, without contents, only 12 topics in this hierarchy. About 200 students participate in this year, and the objective of this experience was checking the hypothesis that when you get enough documents and enough votes from notable peers, the results is a reasonable description of the topic. The mechanics in this year was the following. The students were grouped in communities, and they had to produce a small document about a given topic, and then they have to vote for the free best paper on the same topic. And the structure, the professor graded papers independently, and this grading was used to check the adequacy of the voting system to capture the quality of the documents. This graph shows the result at the end of the first year. Each column represents a topic, and the left side of each column is the ordering proposed by students, and the right side is the ordering proposed by the structure, by the professor. Documents in top zone collected the 50% of total vote in each topic. As we can see, for most topics, the two most popular papers collected 50% of the total votes. This shows us that there is a great consensus, that is, users that belong to a community are agree with what papers are good and what others are not good. Moreover, there is a consensus in quality articles because it's supposed that the objective opinion of the professor is the measurement, as we can see. In 10 out of the 12 topics, at least 2 of the 3 best papers selected by the structure as the 3 best papers were also selected by the student as such. And the second and third year, the next years, students were grouped in communities too, and they used the NOCA site generated the previous year, but at the beginning of each year, the documents with a low crystallization degree were removed by the system, and that in this year they have to produce, firstly, 3 votes for the 3 best paper of a given topic, next, to contribute with a document, and finally, to vote for the 3 best paper on the same topic too. And in this case, they could score not only veteran papers, but also the new one through the system voting mechanism. And finally, this year, the results are the following. In 50% of the topic of the initial 3 structure have in their first position document that have been added that in the second and third year. That shows an evidence that knowledge in the system is in evolution, and it's possible for a document that arrived later to crystallize and achieve the first position of the rank. And about the other 50%, in the other 50% of the topic, the description selected as the best that in the first year obtained so high crystallization degree that description added in following year were not able to reach it. Okay, it is justifiable that about 10% of this topic may contain the best description in the first year. Or it's possible when a topic has little participation, it appears. This happens in about 20% of the topic that had little participation. The other percentage is being studied in this moment. And about the second experience was the generation of a NOCA site about a certain reasoning by a graduate student of computer science. About 10-15 students each year are in this course. The objective was to check the flexibility of a group of students making a good structure by using our proposed voting mechanism. For this point, we propose only initial root node with the name of the course, a certain reasoning, without any topic more and without contents, only the root node. In this case, the mechanism, the work of the student was to propose a structure to the knowledge area and give their opinion about the proposal of other classmates, but they could add documents about the topic and vote them too. Finally, 3 years later, this is the structure, and the structure has been improved along these years successfully, because the number of topics in the current structure is almost twice the initial number of topics of the structure that was created the first year, and the tree structure is 5 level deep. And in the opinion of the professor, the resulting structure contains a credible overview of the topics of the course, a certain reasoning, and the crystallized paper show a high quality. Finally, to sum up, NOCAT As I said, it's a web-based system that allows us sharing, evaluating, and structuring community knowledge that is possible through the knowledge crystallization process supported by virtual communities of experts, and enables the building of websites where relevant knowledge about an area or topic can be found. And the experience have shown evidence that the system is useful for motivating communities in sharing their knowledge, and incrementally constructed an active repository of knowledge of reasonable quality. But we have identified several open issues in the content of our approach, more related with the necessity of mechanics that extend the way to spread the user opinions. In the first place, for example, currently when a user submits a document of a topic, this document is identified as an element. And if later he or she apport another document as an improvement of the previous one, this document is another element in the system. So we have noticed the necessity of document version control in charge in charge of checking that the new version respects the contents integrity of the previous one. And another example is when an author makes a document and another author wants to make a version of the other document of the other author. In this case, who will be the owner of the new document? In this case, we prefer to treat this new apportation, this new contribution with another knowledge unit that is as a node of a document in this case. So we have identified these two new knowledge units in the system, not only documents and structure. These new knowledge units are version document, true, and node of a document. That's all. Sorry. You can get more information about this research in this web address. Thank you very much for your attention.
Okay. Thank you, Ms. Kobos, for sharing your interesting system with us. Okay, any questions? Yeah, please, you can come to the mic.
I wanted to ask, how do you get academics to contribute to this system? How do you stimulate them to actually share their knowledge?
About the motivation?
Mm-hmm.
In our case, all the students contribute because at the end of the course, if they do a good document, his or her document receives favorable opinion, a lot of votes, then his note, his qualification at the end of the year go up a lot. Then the qualification is the motivation for students, in our case. It's a voluntary work, and this year was well. Okay? Thank you.
More questions? I have a question of my own. Have you been able to measure the impact of the system to the learning experience?
Yes.
Did these students get better marks because they used the NoCat or was it the same? Did it help them to learn something?
Yes.
Facilitate the learning process or not?
A little. At the end of the last year, we did some questionnaire to students, and most of the students say that they prefer to learn about documents made by students because the vocabulary, the form of explain is more nearest, and they prefer this explanation that the professor explanation is the most idea at the end of the year.
Okay.
Thank you.
Are there any more questions? If not, thank you again, and please, ladies and gentlemen, let me thank both of our speakers again.
Thank you.
For the nice session, and thank you all of you for being here, for your time and attention, and of course, thank to the colleagues on the internet who spent some time with us.